And the last type of sum that you may be asked to take is a trapezoidal approximation, where you'll be given, once again, a table, a value, say, of t, a function h of t, and you'll be asked to use a trapezoidal approximation with, say, 4 subintervals to estimate the integral from 0 to 10 of h of t dt. And so this is actually very similar to a midpoint Riemann sum, and I'll kind of show you what I mean by that. So once again, let me go ahead and draw out this graph here, and I'm just going to be very approximate here. At 0, we're at 66, and then at 2, so at 2, we're maybe at 60, so I'm just going to say that this is 60. At 5, we're at 52, so I'm just going to say that this is 52. We're at 44 at the next data point, so at 44, this is at 9. And then we're at 43 at 10. So here is 43 right here. And the values on the x-axis are 0, 2, 5, 9, and 10. And so our function h of t is going to look something like this. It'll be downhill. This is h of t. And we are going to be asked to use a trapezoidal approximation, which basically means that we are going to use the average of these 2 points as the height of our triangle. So the average of these 2 points is going to be roughly this midpoint right here. And so the area of our triangle is going to look like this. Similarly, we're going to take the average of the next 2 points, these 2 points. The average looks like about there. And this is going to be the height of our next rectangle. And then we'll do the same thing for the next interval. We'll take the average of these 2 points and use that as the height for our next approximating rectangle. And lastly, for this last interval, we'll use the average of these 2 points as the height. And this is the area for our last approximating rectangle. And so how do we actually write this out and think about it? Well, I'm going to zoom out here for a second. And I'll write that the integral from 0 to 10 of ht dt is going to be approximately equal to the height of this rectangle, which is the average between these 2 data points. So in other words, this would be 44 plus 43 over 2 times the step size from 9 to 10, which is 1, plus the height of this rectangle, which is the average between these 2 points, 52 plus 44 over 2, times the step size from 5 to 9, which is 4. Kind of running out of room here. I'm going to scoot to the right. Plus the height of this rectangle, which is the average between this point and this point. So 60 plus 52 over 2 times the step size from 2 to 5, which is 3. And lastly, plus the height of this rectangle, which is going to be the average between this point and this point. So 66 plus 60 over 2 times the step size from 0 to 2, so times 2. And so if I go ahead and multiply and add those all together, I will get that this is equal to 529.5. And so I can say that the integral from 0 to 10 of h of t dt is approximately equal to 529.5.